Let's look at some examples where we put these into use. For number 1, we're trying to find the sum from the first term up to the 20th term of k squared. So k squared is our second example up here. So we're going to use this formula. This time our n, our number of terms, is 20. So we have 20 times 20 plus 1 times 2 times 20 plus 1 all over 6. So we get 20 times 21 times 41 all over 6. So our sum comes out to 2,870. With number 2, we're finding the sum of k cubed, so we're using the third example from 1 to 10, so we have 10 times 10 plus 1 all over 2, that whole quantity squared. So we have 10 times 11 over 2 squared, and that one comes out to 3,025. For number 3, this one we're using one of those theorems from earlier on the first page. We have a constant here, so remember we can just take that constant and bring it out front. So it's like having 3 times the sum of k from k equals 1 to 15. So that 3 can stay out in front, and when it's k, remember that's the simple one, we just have n times n plus 1 over 2. So we have 15 times 15 plus 1 all over 2. So it's 3 times 15 times 16 all over 2, which gives us 360. Let's look at one more together before you try a couple on your own. For number 5, this one we want to break apart. We have 3 parts here. We can split this up using those different properties of those theorems that we talked about. First one, we're just going to have the sum of k squared from k equals 1 to 10 minus, remember this constant can come out in front, so I'm going to do that right away, minus 2 times the sum of k from k equals 1 to 10 minus the sum of 8 from k equals 1 to 10. So our k squared for that one, remember we're going to take n, so 10, times n plus 1, which is 11, times 2n plus 1, 21, all over 6. Alright, so we're just using this formula right here, n times n plus 1 times 2n plus 1 all over 6 for that first one, minus 2 times the sum of k, we just have n times n plus 1, so 11, all over 2, minus the last one is just a constant. So that fits the one from the other side, the first one we looked at, first theorem. That one's just going to be 8 times the number of terms. We end up getting 385 for our first one, minus 110, minus 80, which gives us 195. Alright, I'd like you guys to go ahead and try problems 4 and 6 and see if you can get those done in a minute and a half. Halfway there. Ten seconds. Alright, check your answers. For number 4, you should get 14,350. And for number 6, you should get 374. Right. For number 4, you can pull out the constant and then use that sum formula. Number 6, break it up into 3 parts, pulling the constant out of the second one, and using all the second and third formula from the top, and the constant theorem from the first page.